Moondust eLearning presents the Moon Twins as they teach you about population ecology. In this video, Ecology Part 2, you will learn about exponential and logistic curves. Be sure to visit the Moondust eLearning store on the Teachers Pay Teachers website using the URL shown here to get your free follow-along handout as well as many more resources. Let's get started. A population of organisms that seemingly have unlimited supplies and resources can display an exponential curve. This is known as the J-curve. With the J-curve, there is plenty of food and shelter, even with births exceeding deaths or immigration exceeding emigration. Immigration is the entering of individual organisms into a population, and emigration is the leaving of individual organisms from a population. It is said that the human population of the Earth is in an exponential curve for population growth. The human population is increasing every year. Once an exponential population hits its limiting factors, the population size starts to plateau. This plateau of the population is called the carrying capacity. The carrying capacity exists when the number of deaths equals the number of births. Also, if the number of organisms coming into a population and the number of organisms leaving a population are equal, this can become carrying capacity. Establishment of carrying capacity is called a logistic curve, also known as an S-curve. A good example of a logistic curve is a yeast population. If you put yeast, sugar, and warm water into a bottle, the yeast will begin to grow in population size exponentially. However, after a while, the sugar will eventually run out as overpopulation takes place. The population chart will eventually level off, and then there will be a decrease due to toxins from waste and overcrowding. Limiting factors that are caused because of the size of a population are known as density-dependent factors. These factors include food availability, disease, and the number of predators. An example of density-dependent factors taking place is bacteria in a petri dish. Bacteria in a petri dish can become very toxic if contaminated. An uncontaminated petri dish will be clear. Limiting factors that are not caused because of the population are called density-independent factors. These factors can include climate, weather, and natural disasters. Some populations can experience a sudden rise and decline in population according to the seasons. These aphids will dramatically decline when the temperature changes. The temperature change is a density-independent factor. Now you have learned about the exponential and logistic curves as part of the study of population ecology.